If you want to follow along, I recommend this dbfiddle website. It's a free website and you don't even need to create an account. When you open the website, just click on SQL Server, that's the flavor of SQL that we're using for these videos, and make sure you choose AdventureWorks as the database. That will give you access to all of the same sample data that I'm using in these videos.
Today we're going to talk about doing conditional logic in SQL. Now we know how to do this in Excel quite easily. We use the IF function, and we'll see that SQL has an equivalent to the IF function, but it also has something new, something that we haven't seen before in Excel to make lots of if conditions a lot easier to work with. For this video, we're going to use some sample data that I've thrown together just to keep things simple. This means that you won't have access to this data in the AdventureWorks database. It means that if you're following along in dbfiddle, you won't be able to run the same queries that I'm running. However, I will include some SQL code that you can use to run my queries in the comments or in the description below. For these examples, what we're going to do, we're going to keep it simple. We've just got some people, some ages. We're just going to categorize these ages into child, teenage, and adult. But to keep things super simple, we'll start with just child and adult. So let's do it in Excel first. To start with Excel, let's add the new column that we're going to be calculating. Let's call it age group. Now, to categorize these ages into child and adult, we just need to check whether the age is less than 18 or not. So very simply, we'll start with the if function. We'll check whether the age is less than 18. If it is, we'll categorize them as a child. Otherwise, we'll categorize them as an adult. When I hit enter on this, because we're using a table, it's going to autofill the rest of the rows for me. Looking at the first four ages, this has done exactly what we expect. These are both children, these are both adults, and interestingly, if Excel doesn't see an age, it's going to default to that first condition. It's going to go to child. Now let's do the same thing with SQL. How would we do this? Well, to add a new column, we're just going to start writing a new column. Easy as that. Now, I mentioned that SQL does have an equivalent to the if function, but we can't just use if by itself. We have to use IIF, immediate if. There's reasons for this which I won't go into now, but just remember if in Excel is immediate if in SQL. But other than that, it's actually almost identical. If the age is less than 18, we'll use child, otherwise we'll use adult, and let's give this the name age group. I've updated my code, let me run it, and here we go. So this is interesting. Everything agrees except for that last row. Excel has used the value child. SQL's use the value adult. Although nulls and blanks, we've seen before, nulls and blanks are really similar in SQL and Excel. The way that SQL and Excel treat these values is quite different. So when you're working with SQL, and I'd even recommend doing this in Excel as well, but always check whether there's null values first. Account for the null case first, and then move on to the non-null cases that for the values that look like what you'd expect. So how do we do this in Excel first? How would we account for this missing value? Well, it's quite simple. We'll just add in another if condition. So let's set up our brackets. All we're going to do is we're going to check if age is blank, then we're going to use unknown instead. Otherwise, we'll go off and we'll do the age check like normal. Just to confirm, this has indeed updated the rest of them. So now we're getting unknown when the age is missing, which is more like what we'd expect. If we don't have an age, we can't really make a claim about whether they're a child or an adult. And how would we do the same thing with SQL? Well, we can just wrap it in another immediate if call as well. So let's just wrap this in another immediate if. Now we can't do what we've done on the left. We can't just check whether it's blank this way. Remember, when we're dealing with nulls in SQL, we specifically have to write the words is null. Now if it is true, we want unknown. Otherwise, we'll go and we'll do the condition like normal. Let's give this a run to see what we get. Now the left and the right match up. They both show unknown when we don't have an age. So accounting for these nulls is such an important part of working with both Excel and SQL. It's a really important thing to get into the habit of doing. Even if you're not moving to SQL right now, even if you're just sticking to Excel, account for the missing case first, and then you know you can trust everything else. You can go and do the rest of your logic like normal. Now let's add the teenager categorization as well. We'll do this in Excel first. So we know we want to keep the age is missing check first, so we don't want to put it before this one. So we're going to have to squidge it in somewhere at the end here. I'm just going to put these on a new line to give me a bit more space. Bear me 2 seconds. So we know we don't want to fiddle with this one. So let's do something with this one. I think we want to do something in here. I think we want to do, if it's less than 13 first, we'll say they're a child. Otherwise, we know they're less than 13, so we'll check whether they're less than 18. And if that's true, we'll say they're a teenager, because they're going to have to be 13 or older. Otherwise, we'll then finally say they're an adult. Let's check this out. Let's see how this works. Here we go. So 10 is child, 15 teenager, 18 adult, 23 adult, and we still have the unknown like we expected. So this seems to be working well. We like this. That's good. But this is getting messy. This is starting to get very, very messy. So we could do exactly the same thing in SQL, doing another nested immediate if, but SQL has an alternative set of words that we can use so that we don't need to keep nesting lots of if statements. These special words are known as the case statement in SQL. So let's set one up and we'll talk about the separate components of it. So this case statement always has a start and an end. It starts with case and it ends with end. So I'm going to also call this age group, and I'll put case on the end so that we know it's slightly different. What goes inside case end? You can think of these like the brackets for a case end statement. This is the start, this is the end, but what goes inside them? Well, inside a case end statement, we have several conditions. We start those conditions with when. And these whens, the conditions that we write after when, are exactly the ones that we've been putting in the first parameter, the first argument of the immediate if or the if call. So let's take this first one. We're saying when age is null. What do we want to happen next? Well, let's say then we want to use the value unknown. I'll put this on a new line as well. So we're going to add more to this in a second, but case and end, that's the start and the end. We then write when to check for a condition. And to say what we want to use, what we want to happen if that condition is true, we then write then and the value that we want to use. So when the age is null, then use unknown. What else could we do? Well, the next condition, when age is less than, we'll do the one that's on the left, we'll do the teenager one. So when it's less than 13, then we want to use child. Similarly, when they're less than 18, we want to use teenager. And finally, if none of those conditions are true, otherwise or else, we want to use adult. Now, the order of the whens is important here. The order of the whens here are like the order of the nested ifs. Just like nested ifs, the leftmost one is checked first. In SQL, the topmost when is checked first. So when age is null, if this is true, we'll use unknown and then we'll stop looking at the rest of the conditions for that particular row. We'll walk through this in a second, but let's run this just to see what the output is. Now this output is exactly the same as the one on the left, the Excel version. We've got the child, we've got the teenager, the two adults, and the unknown. But writing a case statement is so much clearer, it's so much nicer than using lots of nested if statements or nested immediate if statements. So the case statement, we could have done immediate ifs, lots of immediate ifs, but the case statement just means that our logic is so much easier to follow. It's so much easier to read, it's so much easier to extend. So it's actually really rare to see immediate if in SQL. You'll see case statements far more commonly, just because they're so easy to extend. So let's actually walk through what's happening with the case statement, just to make super sure we know what's going on. And we'll go line by line. So we'll start with line 1, age 10. When age 10 goes into this case statement, we're going to go case by case. So we're going to check the first case. Is 10 null? No. So we skip this, we move to the next condition. Is 10 less than 13? Yes, it is. So we use the value child and we don't look at any more conditions for that row, which is why age group using the case statement is child. Let's look at the next one, 15. We go right to the top again. Is 15 null? No. So we skip this bit and we move on to the next condition. Is 15 less than 13? No. So we also skip this bit and move on to the next condition. Is 15 less than 18? Yes. So we use the teenager value and we don't look at any other conditions. And that's why we end up with teenager in this column. Now let's do the same thing with 23. Is 23 null? No. So we skip to the next one. Is 23 less than 13? No. So we skip to the next one. Is 23 less than 18? No. So we skip to the next one. But in this case, there's no more whens. So we jump to the else. And we're going to use adult instead. Exactly the same with 18. 18 is not null. It's not less than 13. It's not less than 18 because it is 18. So we use adult for age 18. And finally, for the null value, is null null? Yes. So we use unknown and we don't look at any more of the conditions for this row. The last thing that I'm going to mention, and I'm not going to pull out an example for it, I'm just going to mention that you can do it. Inside the immediate if, what you have before you return whatever the true value is and the false value, this is some conditions. But it's just like the where clause. If we have one condition, say age is, I don't know, less than 13, and we want a second condition, we can just write and then whatever that second condition is. Maybe is age is not null. So now both of these would have to be true for us to hit the true branch. And it's exactly the same with case as well. In case, we can write combined conditions after the when. And then after that, we'd write then whatever the true value is, otherwise whatever the false value is with the end. In Excel, we can do the same thing, but we'd have to use the AND function. So this is the Excel equivalent. We'd have to use the AND function to combine the two of these. And like this. That's just how Excel is designed. But SQL's flexible. SQL's so flexible. We don't have to write and as a function and provide our conditions. We can instead just write and in between the conditions to combine them. There's also or, just like with the where clause. Anything that you can put in a where, you can also put here and here. This bit isn't about writing SQL. This is more about how you might organize your data, and it applies to both Excel and SQL. But what we've just been going through, it actually makes a bit more sense to keep in a lookup table. So if we were in Excel, we might set up a lookup table that looks like this. From 0 onwards, they're a child up until 13, and 13 onwards, they're a teenager up until 18. 18 onwards, they're an adult. And then the if function that we need to use for the age group becomes a lot simpler. We don't need any nested ifs. We just do the check to deal with the missing data, and then we just do a lookup. With Excel, it's very easy to set this up. Just put it on an extra sheet or on a table next to where you need to use it. This is a little harder to do with SQL because if you don't have permission to create tables, then you can't really create these lookup tables to use. But the best practice in SQL is to always have lookup tables or to generally have lookup tables for things that are well defined, like an age group. If this is some business logic that we wanted to apply everywhere, it makes a lot of sense to centralize that, put that in a lookup table, and then get everyone to just use that lookup table, rather than hard coding this mapping between the age and the age groups in the actual code itself. This is just an FYI though. You don't need to worry about this too much if what I'm saying doesn't make too much sense. So to wrap up, we've seen that SQL does have an if function. It has immediate if, IIF, which has some conditions, and then whatever the true output is, whatever the false output is, just like with Excel. And if we start seeing nested if conditions, we can replace those with case. Case, we then write when, whatever the condition is, then whatever we want the true output to be, else, whatever we want the false output to be, and we always have to end case with end. One of the nice things about case is that we can extend it. We can write multiple whens if we want to. And this is the real power of case. It means that you don't have to have nested case statements or nested immediate if calls. You can just write when, with else right at the very end. It's a really extensible way to do conditional logic in SQL. I hope you found this helpful, and we'll catch you in the next one.